I think I'll have the glasses.
Yep.
They're I can remove them if I get bored.
Sure. Yeah. Okay,
They're good. They do put everything in focus.
Yeah.
It's quite good.
Good to be able to see clearly. Yeah, definitely. So thanks for agreeing to have a chat. So I guess I want to do just a little bit of an introduction. So my name is Ben Denham, and I'm a lecturer in drawing at the National Art School. And you, Joyce Hinterding, tell you something that you don't know. You're a senior lecturer in and director of research at Sydney College of the Arts, and represented by Sarah Cottier Gallery. And I think you're doing some of the most interesting drawing work of any artist anywhere. So I'm really happy to be having this chat with you. Hopefully about
I must say, you're up there with me. I don't think I stand up here alone.
Well,
there are a few other people, and you're one of them.
Yeah. Thanks, Joyce. And I guess that's partly why I wanted to have a chat with you, because I think there's a kind of an affinity in our practice, and more generally, I guess I'm interested in having this sort of conversation because I think a huge part of our discipline is conducted through chats, through conversations, both in terms of teaching. But also, that's often where the work lives in many ways, is in the conversations that we have about it. And in that sense, I think that visual art is kind of an oral culture in some ways. That the written word has some kind of importance, but I think so often it's the conversations that we have that are really important in how we think about what we do. So so there's kind of like a bit of background to why I wanted to have this chat. So I guess the main thing that I wanted to talk, obviously you've done all sorts of things with your practice, but today I wanted to kind of focus on the drawing aspect. So we've got an example here of
quite an old one.
Right. So where does this fit in terms of your drawing work?
I'm one of those people who was always drawing as a.
Yep.
In my HSC,
yeah.
I presented a drawing portfolio.
Right.
And
what was in your HSC drawing portfolio?
Lots of trees with bodies hanging out of them, and I spent way too much time with an anatomy book and got into a lot of trouble because it all looked a bit too much like Salvador Dali, and people were very dismissive of it, which was pretty funny at the time. But I ended up going to Paran Art School in Melbourne, and then after a year I decided that I might like to do drawing full time.
Right. And
to get into the drawing course at Paran, you had to do 3 solid days of drawing. And so they'd set up the studio, and you had to go in there and.
This is like a drawing examination.
Well. You just had to spend 3 days.
Yeah, okay, right. Whoever makes it through the 3 days is kind of attrition.
If you were still kind of wanting to do it after you'd spent 3 days solid drawing, you got in. I loved it, but I ended up going to jewellery and gold and silversmithing, and I felt like I wanted to understand more about materials and material science, which I think in some ways those two things sort of came fully back together again as I kind of started to study electronics, actually. It's funny, isn't it? Yeah. I started studying electronics, and I found a children's book, and in the children's book it explained how you could use a pencil to draw a resistor.
Right.
Yeah, the graphite is resistive and conductive.
Yeah.
And
so to draw a resistor, or the graphite itself would be the resistor.
Yeah, well, you could use the pencil or you could draw with it. This is many years later, after studying electronics and then teaching. It was actually at the point that I went to teach electronics at art school that I read the children's book on electronics, because I thought that would be good to understand, I guess, what the bottom line was. And it kind of blew my mind. And so that took me back into drawing in a really big way. And at that point, I think at that stage I was studying electronics, and the very first thing I did with that was draw on a piece of paper and then attach a whole lot of light globes and heaters to the other end with bulldog clips and graphite, and then I guess made it really attractive to get across. Right. So put lots of things that needed electricity on the other end.
Sure. So like a big drain.
Yeah, it was like a drain, and it just kind of suck it across. Yeah. And it did.
Yeah.
It sucked it across, and I think so. That's probably the first thing that I did. It was just a photographic experiment with lots of burnt paper and
paper burnt by electricity.
Paper burnt by electricity with lots of light globes and one of those old heaters. They were like 1,000-watt heaters hanging on the other end.
Like an oil field heater or something like that. Or
like
bar
heater.
Bar heater.
Right.
Okay, wow.
The ones that used to really kind of drained electricity.
Yeah.
So that kind of begins that. And then, of course, the drawing of a resistor, which is a zigzaggy line.
Yeah, okay. In the electronic diagrams,
it's a zigzaggy line.
Yeah.
And so the drawing of a resistor that becomes a resistor is, that was another thing that kind of blew my mind, which was that's the sign of the thing that becomes the thing.
Absolutely, yeah.
And there aren't many things in the world where the sign of the thing becomes the thing. It's kind of some kind of religious experience, I think.
Sure. So what would be some other examples of where the sign of the thing becomes
eating,
the thing? The Eucharist.
Yeah, the Eucharist, I guess, eating Christ. And, my friend Paul de Marinis made a hologram of a record.
Yep.
So it's an image of a record, and he plays it with a laser.
Yeah. Okay.
So that to me is the image of a thing that functions as the thing.
Yeah.
Yeah. So I don't think it occurs that often.
Yeah. Yeah. And it's definitely there in the because the record is the physical waveform, right, in vinyl, right? It's the light form.
Yeah, it's trapped inside the.
Yeah.
Well, the hologram of the record.
Yeah.
Yeah. So there
but
are
the record
other things.
is already kind of that, isn't it, in some way?
Well, it's really it's like it's a piece of rock traveling through a valley and bumping around. The piezoelectric crystal in the stylus goes through a little vinyl valley and gets bumped around and then produces the tiniest amount of electricity, actually. It's why the input for your record player is it's a very high gain. It's got a preamp on it. So you really have to turn the signal up. So that process of, I guess, it's fascinating, that kind of thing where you work out that even the most everyday thing like the record player has this amplification becomes absolutely critical to that sensitivity.
Yep.
So it's not just so it's not obvious, I guess.
Yeah. And that's this kind of thing of taking a signal that we don't generally hear and making it audible is clearly something that you're quite into.
And of course all of that sort of thing. I guess the thing that comes before that is is this thing about the sign of the thing becoming the thing is really significant.
Mm-hmm.
And that goes on to be capacitance and storage. And there are concepts in there too. There's resistance as a concept. There's conductivity as a concept.
Sure. Yep.
There's capacitance as a concept. And all of these things kind of mean something at some other level as well. I mean, you know, we have capacity.
Yeah, sure. Yeah, so there's this kind of whole, like this kind of translation from like quite a concrete physical thing in the electronic circuit or in your drawings to kind of more philosophical kind of understandings of what these things might be.
Yeah. I think that travels with it, or maybe just even opening up that language, that relationship between the psychosomatic and the physical world that we conduct, we hold energy. I mean, the first piece of electronics I ever built was a theremin that works with two heterodyned oscillators that produce a difference tone that you can interact with, and it's so sensitive that your body capacitance, the energy that's just in your body, is enough to change the oscillation,
and then
you
pitch.
Can hear it. So you can hear that. Beach Boys kind of thing.
Sure, yeah.
Yeah, so that sort of thing about, you know, body capacitance and then drawings having capacitance, having the ability to store energy.
Yeah, well, that's a really interesting thing that I think links what you do to maybe more traditional forms of drawing, where, you know, say for example, like you know, expressive mark making, where to me there is this kind of record of the energy of a body on a surface, and you know, and we're responding to that when we look at those expressive marks. And you know, and when they speak to us, they're almost inciting that same energy in our bodies. You know, like there's this kind of this sympathetic kind of resonance that happens with the expressive marks.
Yeah, I mean, I think there's a shift from the time, just for example, from the time that I started working with graphite in the must have been the early 90s, really.
This is when you drew your first resistor. Had your drain kind
of
power
it's
drain.
Really, it could be even earlier than that, actually. So it's like, I'm trying to think of what it is on the date on there. I think it's like 87 or 88.
Yep.
Begins around that time. And then by 1991, I had 300 graphite-covered beer glasses that was acting as a huge capacitor inside a very tiny little circuit that was in the Art Gallery of New South Wales for the 1991 Perspecta. And that thing filled and emptied with electricity and terrified people because they were like, oh my God, this thing is poisonous and smelling and it's electrical. And it was, the most fascinating thing about that was 10 to the minus 12 as a quantity. So if you put 12 zeros behind the decimal point, that was how much 12 volts was emptying and filling out of the glasses.
Right.
So that's how sensitive we are to both. I mean, it's interesting when you talk about expressionist drawing and things like that. So there's this graphite field that is literally, I mean, and the sound was doing it because there was a certain sort of sleight of hand because there were three sounds that were playing. One was the sound of a pink noise generator, which is the sound of atoms, electrons crashing into atoms inside of a silicon chip.
Right. That's the pink noise represented that, or
it was that. That's what generates it.
Okay, right. Yeah, no,
it's just
true.
Again just this amplification of that.
Okay.
And then there was also a little oscillator that was playing the resonant frequency of the jars. So I took a microphone and found out what the resonant frequency of those beer glasses was. And what was the other sound? I think that was it. There was just those two sounds. Oh, there must have been And I think there was a 50 hertz oscillator. So there was sound of electricity, our familiar sound of electricity, the sound of electronics, electrons crashing into atoms, and then the resonant frequency, the whoo
of the beer bottle,
of the beer things. And so the resonant frequency located the sound into the glasses, and then the volume went up and down as it filled and emptied. And it was just, it amplified, I guess, what was going on in that situation. But, you know, but it just goes to show that sense, the sense of storage in graphite was, even at that point, was really strong. I mean, it isn't until much later that graphene is discovered by the two Russian scientists who won the Nobel Prize, and they discovered it with sticky tape and a pencil. So, and that's a long time, you know, that's a long time between that. So for a long time, graphite just belongs to drawing and art making and artists, and maybe to locksmiths. Sure. When as a lubricant.
When your key gets a bit sticky.
Because I just went looking for a liquid graphite at that point in the sort of late 80s. And I discovered a company that made a liquid graphite that was used as a lubricant. And I bought...
this is the industrial use of graphite, right? It's a lubricant.
A lot, mostly in casting. Because you can heat it up and it doesn't disintegrate, so you can paint your cast in graphite and your cast will pop out. Even if you've poured something molten metal into it or something like that. So it can withstand very high temperatures. And so, so this turns up, a bucket of this stuff turns up in, you know, I find it from some company out west in 1990 or 1989. I think.
Go to the warehouse, drive out there.
It's called, you know, this crazy stuff. And that's sort of what painted the jars. But that is a long time before graphene is really negotiated as being an electrical.
Right.
Or having some kind of electrical.
And all the uses they're now kind of spouting about, you know, what it can do. As,
all that sort of energy relationship. It wasn't there at that point. So it was really fascinating that energy relationship really came from artists and drawing.
Oh, that is really interesting, and it kind of goes to. You know, one of the other things that I wanted to ask you about, which is kind of what that relationship between, you know, different ways that, you know, we as artists might approach materials and the way they, you know, that say a couple of Russian scientists might grab a pencil looking for some new fancy thing. You know, what do you think about, you know, the differences in approaches to materials from, say, an artist or a material scientist or a scientist?
I think that the fundamental difference, and certainly is the question of efficiency. So nearly all of contemporary engineering and science, and let's say all of STEM, science, technology, engineering, what does M stand for? Mathematics. It's all about making it more efficient. Whereas I know for myself, I mean, the big thing, even back then, was I thought, well, I'm only replacing a 50-cent component in an electronic circuit with these 300 beer glasses, and they kind of smell a bit because they put ammonia into the graphite as a preservative. So it's just water-based, but it has ammonia in it, just stops it from going off. So it has this little bit of ammonia smell in it. So it's smelly, a little bit frightening, a little bit kind of, and big, really big. And it struck me at the time that, you know, there was this terrible hegemony around electronics, was that it all had to be small. And it all had to be efficient. And in fact, if you didn't think about it as being small and efficient, and you started to think about it as being big and wild, and maybe it took up the whole side of a building, or but it only delivered a little bit of energy, or it didn't have to be small. And I kind of opened up this whole question about functionality. Things function in the world. Things are active, but we often, because it's only small. And you think, well, big things shouldn't produce small amounts of stuff, small amounts of functionality. If it's a small thing, and now we've got lots of small things that produce incredible amounts of efficient activity, in a sense. From mobile phones to every device has sort of shrunk. And so I think as an artist, I went in the other direction, because inevitably you're in an art gallery and you've got big spaces.
You've got space to fill.
You've got space to fill. So, as much as I've come out of as studied jewellery and all of that, I actually like the larger expression that comes with, I guess, sculpture and painting, and the scale is what is really interesting. So it's, in a sense, that's the difference. Art, as an artist, to have gone in the opposite direction to the direction that science and technology was going in, which was about making everything smaller and more efficient. I just went bigger, less efficient, still working, still working.
Sure, yeah. And the other thing that pops out from what you're saying for me there is that that and that I think is really important to our discipline is this idea of thinking in space, of taking something that might occupy a really tiny space, and what happens when you blow it up, and what possibilities for thought does that allow,
because it totally takes it out of the box. I know at one point I started to look at photosensitivity. So photovoltaic, we've got the dinosaurs.
The cockatoos, classic.
If you're in Sydney, you'd have aeroplanes. If you're in the Blue Mountains, you've got dinosaurs. Lots of them, I went to see Martin Green, the very famous scientist who's working on the photovoltaics, which are now the most efficient photovoltaics in the world, at UNSW. And I talked to him about this idea, about being less efficient but still working. And he gave me someone's research paper to read, which was on copper, and how, and if you heat copper up and you drop it into cold water, you get like a reduction. It doesn't oxidize, it reduces, and you get like this bright red surface on it. Right. And it's photovoltaic. Right. So it produces a voltage when it's exposed to the sun, but there are a lot of other things that do the same as well. So there's, I've never seen a solar panel that...
A bright red copper solar panel.
I know. Well, he said to me, well, it was fine. He said, but the problem is it'd have to be really big. Right. And I was like, fuck, that's great.
I can do big.
That sounds perfect. Take up a whole wall, and it's reactive. Great. Yeah, so I think there's an enormous opportunity still sitting there around thinking around efficiencies and materials and functionality, and whether things still function, but they don't function very efficiently. And I think there has been some shifts in that thinking now, particularly covering solar panels.
Like on roads or on...
People are starting to look at, I guess, the photovoltaic functionality of different kinds of materials that is less efficient, but covers huge surfaces. And roads. I think roofs and roads, glass,
windows on the side of
so they're looking at very inefficient systems, but that can be applied to industrial processes.
Yeah. I mean, the other thing that occurs to me in what you're saying as well is that there's that tendency, that capacity, I think, for artists to be able to think in a way that kind of it runs counter to, whatever the kind of dominant tendencies of the time are. Whether that's kind of miniaturizing things and making them more efficient, or even one example that comes to mind is like resolution, like the question of resolution, right? Like in the photographic realm, the idea that we should have ever greater resolution, and 4K is not enough. Let's go to 8K, 10K, a million K video. And then, there are artists who kind of will work against that. Like, so, for example, Jim Campbell, who makes these very low resolution LED arrays that might have, 1,000 pixels in an array, as opposed to 2 million pixels in a HD display. I guess and I think what comes up with that, and I guess, this is where I'm getting to a question, is that there are poetic possibilities in when you kind of run counter to those kind of questions. And I think you like that I think I'm interested in whether how you think about like the poetic aspects of what you're doing, or if you think about that in relation to your drawing work.
Yeah. It's interesting. It's like, I think for a long time I thought that I was just kind of, that it was all form and function, and that the aesthetics and the poetics that came out of it were almost coming out of it accidentally. And maybe for a certain amount of time they did, because it was being determined by other factors. The poetics that have come out of it is a kind of poetics that isn't necessarily, I guess it's more a kind of metaphysical poetic, because it's kind of concerned with a meta-narrative about how things are working, or the possibility for things, for engagement with some of those things. So it does appear, but it appears almost like not as the primary driver in it, but as an outcome. It's like what appears. I mean, I think in my work, I think that making artwork is about walking around blindfolded for a really long time. And you like, there's a kind of, it's this kind of blind faith that somewhere along the line that is actually going to make sense, or there will be something, it will work, and it will suddenly connect to all these other things. And inevitably in my practice, what happens is that maybe about a week before I start to realise what the poetic,
connecting to,
what it's connecting to, and where those kind of relationships start to sit. And it's like it has this kind of revelation kind of moment inside the process, which is, so it begins the idea and the process, and it's like, oh fuck, I don't know if it's going to work. I don't know if this will really work, and if I don't really know what this kind of, it's like, oh, what are you going to call it? I don't know what I'm going to call it.
We need titles.
We need titles. Write about it. It's like, oh, it's very interesting. I mean, I think I have given some things really bad titles because of just not being close enough to the end to get that moment of where you suddenly see the whole thing. You see all its connections, and you see what it means, and maybe not so much what it means, but how it's unfolding in the world, or how it's relating to other things in the world. And that's what obviously becomes really exciting, because you see it just open up. And so the poetic space of it, it's not something that I feel like I go in consciously trying to do. And yet it arrives almost of its own accord. I mean, someone said to me one time, Tom Arthur said to me one time, this is always stuck in my head, which was, making art is a two-part process. It's one, it's setting out to say something, and then the other part of it is finding out what it is that you've got to say.
Sure.
And so there's this process where you think you're doing something, and you think you're going in this direction, and then you kind of then it starts to talk back, and you see what is coming back out of that investigation, and then of course, and I guess this is one of the processes that I think people really do with drawing. I think people begin a drawing, and I certainly do. You begin a drawing, and it's like, I don't know what I'm doing.
Sure.
I sort of know what I'm doing. I'm going over here, and I'm looking at that, and I'm trying this out, and then it's like, and then what you've done starts to talk back, and then you develop off whatever it is that you discovered. And so there's this double whammy in the process. And I think it particularly happens in drawing.
Yeah, I think that's true. I think that's a really important insight, because it allows us to see what is specific about drawing as a mode of working in the world, and how maybe drawing relates to all sorts of other forms of practice. Like you can bring that drawing thinking to other kinds of making and doing, right? You can bring that kind of, and that's that's conversation that I often have with students, is like, like you might be making a video, but how is this still drawing? In what way can we still think about this as drawing? And a lot of it is in that just being prepared to start something, not knowing where it's going, or and being able to discover out of the process. Which I think kind of drawing in the discipline of making marks on paper teaches us, but then that's a kind of thinking, like I say, that I think that kind of can expand out into other realms as well. A kind of drawing thinking in other, it's like all those painters from the 60s who started making video work, but said, I'm still a painter and this is still painting, like.
I mean, I think that the word drawing has a double side to it. To draw towards you. So it's not just the drawing that you draw, and it's not just illustration or representation or expression, but it also, and this is particularly, I guess, turned up in my work, is that there's the front part of it, which is the drawing part of it, which is the graphic part of it, which is the material graphic kind of exploration. And then there's what it pulls in. And it pulls in, and then these ones actually literally pull in energy.
Which is kind of part of their poetic appeal, right? That's that. I guess that's what I was getting at a little bit with, in terms of thinking about them poetically, because the idea of the antenna is, it is this kind of physical structure, right? It is something that, has a very tangible structure, and its form is in some way determined by its function, as you were saying before, right? But at the same time, there's this sense that it is kind of pulling stuff in, and it makes us reflect on that aspect of art making, I think, not just in drawing, where we're pulling stuff in and hopefully there'll be surprises.
It's like everyone's, everyone's like, draw a self-portrait, It's like, it's like there's so much going on. You pour yourself into these things, and it pulls everything in. It can pull it. They're very good at pulling things in. You could ask this really sort of crazy question, which is, is that the graphite relationship, but it doesn't work quite that way. But although carbon and charcoal and we're still on the carbon axis.
Sure.
This is the axis of old carbon and carbon. I mean, graphite's an allotrope of carbon. So it's just a very stable form of it. A very slippery, stable one. But carbon sits right in there. I mean, and I think about all that beautiful willow charcoal.
Sure, yeah.
We had willow growing in our garden, and you get weed audited.
Sure, and you have to remove that tree from your garden.
You're not allowed to have willow growing in your garden.
Yeah.
And so we were looking at these willow. I mean, the willow is incredible. We were like, oh, well, I wonder how you could make it all into charcoal. But but certainly, again, that materiality, the material relationship between carbon and drawing. Yeah. It's very curious. Yeah. It's a curious one.
Yeah, no, definitely. And it's something that's so it's become so immediate when you play with your works, when you interact with them. You know, like that there is this kind of material dimension to carbon that you know most people are, you know, unaware of in their everyday lives, and you can kind of go in there and realize that it conducts electricity, and that you're when you touch it, it'll, you know,
you'll add your electricity into it, which is what happens in those drawings. So aside from I mean, it took a long time before I understood what was going on with touching it. Yeah. And at first I didn't want anyone to touch it because, you know, drawings are really precious. Sure. And there's a lot of work went into it, and I definitely don't want anyone to touch it. And I'd come in with my rubber. And of course...
This is when, like, you were hand drawing these to start with, right?
Yeah, I did hand draw them, and they were really took a lot of... I mean, I guess it's like any drawing, you put so much effort into it, and then you definitely don't want it to be smudged, but I couldn't stop people from touching it. I remember after one opening, I'd come in with my rubber, and Michaela Dwyer was there, and she said to me, "Don't rub it out." I was like, "Oh my God, you're right." Rubbing it out. Don't rub it out.
It's like because it becomes then a record of all of these interactions.
So and as a result, there's, like, you know, every time the antennas that were drawn onto paper have been on exhibition, I've taken them back and place dated and timed how long they were on exhibition for, and they've basically become the dirty drawings, which is really and then they have kind of exhibited them. I need to put them in an attic and have a dirty drawing show.
Sure,
but but they've really, and some people on some of those drawings, in some places, people have started to explain electronics to other people. Right. And so they've got other components smudged into them.
Oh, really? Wow, the people that have made their own little drawings.
Someone did some, like, diodes and some other things. So it wasn't just this fierce kind of, like, you know, pounding the drawing to, you know, make music out of something that was actually, you know, continuing the drawing.
Wow, and I guess you know the other thing about those traces is that it you know, maybe comes back to that thing of like the energy that people are kind of leaving in the work themselves, right? And the kind of poignance of you know, this kind of long history of drawing and mark making that we have as a species, like going back to the kind of marks that we've made on caves in all parts of the world. And, you know, like those hand stencils, you know, like they have this, you know, this incredible presence still, you know, like when you see those hand stencils, like this is at least what I get from them, you know, like that you see them and you connect with this human who was there, you know, maybe, you know, tens of thousands of years ago and made that mark, and yet they're still present in some way through those marks. So there's this kind of record, you know, in the way that people interact with them, of their presence at that place. So it's, you know, I think
that's really interesting. The drawing is a kind of presencing. Or an evidence of presencing. And that, and there's a really long history there of that people have presenced. And it remains. It's the marks remain, and I guess that's when you look at the expanded field of drawing. And you see mark making of every kind, and realizing that lots of things draw.
Sure.
And, you know,
other creatures.
You know, the wind leaves drawings all over the. There's so many kinds of drawings, and I think that in a sense, I mean, that has a really big influence on me as well, which shifts it away from, I guess, you know, thinking about, I guess where it begins with a kind of drawing electronics. To realising that they're energetic, the drawings are energetic, and then looking back at the world and seeing the drawings that are made in the world, and then looking at the structures that are in the world, and then thinking about how they themselves also begin to become energetic shapes and forms. So it's not just energy, you know, it's not just the resistor, the capacitor, and the inductor, which is our basic set of electronic components.
And that have all shown up in your drawings in various ways.
I mean, well, in the end, probably the last, so they did a lot of antennas. Really a lot. All fractal antennas, because I used to go to the CSIRO antenna conference.
Right, excellent.
And I did, one of the great things there was I listened to this guy give a talk about how to turn a bucket of water into an antenna. And, you know, at that point you go, right, wow, okay. It really doesn't, it's wide open. Sure. You don't have to think about that as like a TV antenna. You know, you can think about this in a lot of different ways. And even though most people weren't, of, you know, 3 days of conference papers, there was just this one guy, and that was incredible, you know. But
the relationship to the landscape, right? Like,
so the guy who was running the conference, he did some work with him, and I got interested in energy scavenging. So the great idea being, wouldn't it be cool if you could just draw an antenna, scavenge some electricity out of the atmosphere in some way or another, and power up your telephone? You know? And it was really cool. It was a really sort of like crazy idea. And I went to the CSIRO and I'm like, what about this? And then public artwork. So I had this idea for a public artwork. It was going to be done on the domain, and it was going to have all these crazy drawings on it, and then it was going to have something that was going to play back the sound. So I don't know if you remember, years ago when mobile phones first were invented, I think we were really aware that it was a cellular network. Yeah, so when you moved from different cells, your phone used to go bing, bing, Harbour Bridge.
Right,
bing, bing. The rocks. And because the cells weren't that big.
Sure.
And we can still see them. But as we pass through the cellular network, it doesn't tell us that we're moving anymore. Anyway, so it's geolocational. It's an energy field that's a geolocational energy field. And Sydney, or here in the Blue Mountains, we have ILS, the Instrument Landing System, outer beacons for the Instrument Landing System on Mount Boyce. If you go, I mean, so all around Sydney
antenna
is the Instrument Landing System, which automates or guides airplanes into the airport.
Right, okay.
And they're a set of tones. You know, so it locks onto a tone, and the airplane knows where to go.
Sure,
So I really love this.
So it's broadcasting these tones, like radio.
Yeah, so this is just one of these kind of radio environments of Sydney. And I thought, wow, wouldn't it be cool if you could use the energy of the mobile phone network locating itself to play back the sound of the Instrument Landing System in Sydney in this public artwork and power it off the mobile phone network, just scavenge energy off it. Anyway, so the
sounds great.
So the CSIRO said, "Oh, you can't do that. You know, that's a bit illegal. Right. You can't suck energy off the broadcast grid." Anyway, they said, but look, we'll come down with you and we'll have a bit of a look around. Anyway, so they came down and had a look at Hyde Park, and they came up with a little antenna. It was a little spiral antenna. And they said, look, this will work. They said, there's a transmitter sitting on that. There was a radio transmitter, so it was a local radio station. And it was actually broadcasting out that way, and it was just throwing a bit of energy back this way.
Yeah.
And they said, you can take some energy off that. They won't even notice.
Right.
Anyway.
Because if you're pulling, it's not like that energy, like does become a kind of drain on that energy source in some way.
Yeah. Anyway, so I off I went with, so it was going to be a big structure. It was going to be like a wall that had all these drawings on it that were going to suck this energy from this tower and play back this set of tones that was, using the energy of being lost, in a sense, or finding yourself to help yourself get home.
Yeah, navigation.
Yeah, anyway, never got funded. But we stayed friends. We stayed friends. Yeah. And he said to me, you really should explore fractal antenna.
Right.
So then I started to draw fractals.
Fractals, yeah.
But I didn't draw complex fractals. I started by drawing old ones, so all the turn of the century ones. So they were, so Mandelbrot comes quite a bit later, but some of those early algorithmic maths is really Cesaro, and there's these fantastic mathematicians who worked out these, I guess basically. Algorithms that would produce a really long line. Yeah,
sure. Right. Yep.
And a line that twists and turns.
And it doesn't cross over itself? Or
no, it never crosses over itself.
Yeah,
it's like a big loop.
Yeah.
So it's like a big induction coil, but they're just really long. So if you had a piece of paper and you were thinking, I'm going to build the biggest antenna I can get onto this piece of paper, then you want to build the longest line you could possibly do. So sure. I didn't have a go at drawing it all by hand, but I ended up on the computer generating algorithmic lines and learning about the mathematicians who wrote the maths for those lines. So that really kind of pushed the drawing in a really different direction. And I really learnt a lot about maths. And I guess there's computer drawing, which enters into that scenario, and stenciling. Because suddenly then...
As the output.
So the output becomes vinyl cut, stenciled, and then still coloured in with a pencil. Right. So we had like a workshop here for, went for a long time really, because everyone wanted to exhibit them for a long time. So we'd be here and we'd have some friends here and we have really
colouring
nice
in sessions.
9B pencils. And we're all colouring this stuff in. And the CSIRO antenna, he was head of microwave and antenna research. Trevor Bird was his name. And that was the other funny thing about Trevor Bird, was that if you really wanted to know something about antennas, then you maybe should really ask a bird.
Right, okay. In terms of like navigation systems and stuff like that, he
knew everything.
Yeah, right.
Yeah, okay. He was great.
Yeah.
Full of good suggestions. Excellent. And he suddenly kind of opened up this whole fractal thing.
Yeah.
And but he said to me, he said, I think because you're actually drawing it, you're doing it with a pencil, that it's lining everything up.
Right.
So
the graphite,
you're pushing the graphite through, and it's just lining the whole thing up. So even though it's gone through this elaborate process of, fractal mathematics and computers and stencil, cutting a stencil, vinyl cut stencil, getting it onto the paper, you're still pushing the graphite through. And the work that ended up in the MCA, which was a phase shift oscillator, that oscillator got more and more efficient.
Right.
Yeah, so it was weird.
As people were...
No, just over time. So
Right.
what was
How does that
happening
work?
was, we were looking at it, and I used to go in with the multimeter and measure all the electrical values in the drawing, which the MCA got really a bit antsy about, because they're like, "What's wrong with your work?" It's like, there's nothing wrong with the work. It's like this. It's changing. I mean, the first thing that happened to that work when it went from, I had a studio at Scott's Church, this is a work called The Oscillators, and it was in Scott's Church, and it was summer, so it was like about 80% humidity.
Right.
And the energy storage system was on both sides of the paper, so it was graphite on both sides of the paper, and then a bulldog clip that connected them together.
Yeah.
And once it got inside the MCA, the paper started to shrink because it's atmosphere controlled and it's air conditioning.
Sure.
And the whole, so I went in and it was going, it was like doing like an oscillator.
Yeah.
It was more like a cicada than an oscillator, because the whole thing was way too big, and it was sort of shutting itself down and keeping on going and shutting itself. So it produced this sort of somewhat staccato kind of sound.
Yeah.
Very much like a cicada. Anyway, I get inside and the pitch was just going up and up and up and up and up. And I'm like, fuck, this thing's just going to, and we've got 3 really big drawings that are just shrinking. And all the electrical values were shrinking.
Yeah.
Anyway, fortunately, it stopped after a couple of days.
Yeah.
But yeah, it's like something you just wouldn't think about how the paper that you're drawing on is...
Like the humidity content and all of these kinds of things.
Yeah, it was just expanding.
Yeah.
And then at the opening, there were all these people standing in front of it.
Yeah.
And they're... What are we? Are we 70% water?
Yeah.
And we're breathing, and we're breathing all this water out, and they're standing in front of these drawings, and the pitch was going down. I was like, oh my goodness.
Wow. Yeah.
And it was really funny because it was just graphite and paper, and the drawing of the oscillator circuit that was now incredibly reactive to humidity.
Yeah.
But it was 6 weeks or something, I think the exhibition was 6 weeks. The graphite the electricity learnt its way through the drawing.
Right.
And it got more and more and more efficient.
Yeah, wow.
And so as it was getting more and more efficient, the pitch would go up. So every week I'd go in and I'd bring my multimeter, check it, and I stopped feeling precious about it, and I'd write the
measurements.
I'd write what it was on the drawing, and then take a rubber and start rubbing it out to make because it was a zigzag.
Yeah.
They were resistors.
Yeah.
They were just big zigzaggy lines, and just made them a bit longer to stop the electricity from finding the most efficient pathway.
Yeah.
Anyway, you'd hear it come back down into hearing range. It'd be great. And a week later, it'd be like, be up here again. You like take the rubber, rub it out a bit more, it'd come down again. And that went on for 6 weeks. And the gallery kind of got to understand, I guess, in the end that, it's an experimental drawing, It's not, maybe it's got a life.
Yeah. Yeah.
Yeah.
Well, it clearly does, like in the sense that of the the energy flowing through it, right? It's like what happens when you put energy into a system, like it will generate these structures that change the like the patterns and the ways the energy flows and all of that kind of stuff. Like it's that aspect of. It does sound alive, right?
It was kind of alive. And then finally it was like, well, Duchamp said, all painting turns black in the end.
Right, yeah.
So in a sense it and I guess, some artworks, that's an interesting idea, isn't it? A temporal artwork.
Right.
Okay.
Yeah.
Most artworks are temporal at some level or another.
Sure.
How long are they going to last for?
Yeah.
Maybe it's only going to last for 2 weeks before it just vanishes in a sense, because the idea was just not quite resolved enough.
Right.
You know,
it's not quite stable enough.
It wasn't good, couldn't stabilize.
Yeah.
Anyway, but probably by we're on the 6th week, it was like, anyway, I was rubbing, and it was like really getting thin, and I couldn't retrieve it.
It was gone.
It was gone. By that stage, you could see, you know, no one's supposed to touch the artwork. It also had silver leaf as storage on one side, and so the silver was starting to oxidize as well.
Right.
Because I didn't want to put any kind of coating on anything, because I just didn't know if that would change it, you know. So it was working. So it was like, but then, you know, don't touch the artwork. And of course, then people are breathing on it, this big wet breath, and they'd get up close to it, and then they'd just have a little touch, just because they needed to touch it. And so all these fingerprints were becoming visible across it as it was oxidizing where people had touched it. It was fascinating, and it was disappearing into some ultra high frequency that you won't be able to hear anymore.
Yeah. Because it just became too conductive, right? Like in some way,
as it became, so the graphite. I mean, it's one of the things now that they're talking about graphite is, you know, even though we knew that graphite is known historically as a resistor.
Yep.
It's not known as a conductor.
Sure.
But now with graphene, one of the issues that is appearing in trying to make it a semiconductor, something that conducts and resists, is that it's a little bit too conductive, and they're having trouble kind of flipping it back to being resistive in the same way that a semiconductor, like a silicon one, because of the silicon, they dope it, and you get a more resistive and a more conductive version of the silicon. Yeah, so in fact it's too conductive. Right. So that's exactly what happened. It just became, even as it got thinner. Yeah. And of course now, on retrospect, you can say, well, the thinner it got, the more conductive it got. Because the single layer, the whole thing about graphene is that it was...
As a single layer, it's hyperconductive.
Super conductive. Yeah. The pictures of it are just insane. Those nano pictures of what graphite looks like as a single layer, but of course it's totally transparent. And you know, but it's fascinating.
No, that's amazing. That and you were saying that somehow the electricity learned a path through it. So that would imply that the electricity is it changing the carbon structure then, or is it just kind of finding the most efficient way to flow through it?
Yeah, no, I think it's its own efficiency. You know, it just. I mean, I guess it's like go right back to that first instance of what I was, or even when you look at lightning. Yeah. And you go, okay, well, how is lightning? What's happening there? It's just finding a pathway. Yeah. And it won't necessarily find, but it will find the best pathway. Yeah. Based on air currents and things like that. Yeah. You know, and those original drawings with the 240 volts running through it, the paper, it found the best pathway that it could find, and that would have been related to how thick the graphite was in different bits of the drawing. Yeah. But it's really, it's very funny. Yeah. So that question of efficiency just flips in both sides.
Sure. Yeah. At a certain point, which I guess is kind of this thing that, you know, where we're thinking about, because it, you know, when efficiency becomes kind of dogma, and everything has to be driven by efficiency, that it does become this false situation, right? You know, like that. Yeah. That there's all sorts of ways in which that is no longer efficient. You know, you see that everywhere in kind of management, and you know, and in practice as well, right? In terms of, I think this is really true of practice, where if you have a sense that an overwhelming sense of urgency. And you don't allow yourself enough time to reflect, then you're probably not actually being that efficient. You know, there's a point where you actually do have to pause and just like relax. Yeah, exactly. You know?
Take your time.
Yeah.
Take a bit more time, and
yeah.
realize that the efficient pathway is not necessarily going to get you what you want.
Yeah.
Might get you there, but might not get you what you want.
Yeah, absolutely. Yeah.
But that kind of the internal structure. I mean, that's something that really, I guess, goes back. It joins together the fractal mathematics, its interior activity, its interior structure, its slipperiness, and the question of carbon, you know, and nature, you know, like what's going on outside, or how things are forming.
Yep. Which kind of comes back to this thing about like that, you know, for me, one of the like that poetic aspect of like, you know, energy, capturing energy, or the antennas as being these vehicles. The other thing that it kind of makes me reflect on are kind of those flow states, right? That are so important in, you know, all different types of activities. But you know, musicians improvising, for example, or writers who are kind of streaming their next novel from you know, from the universe, something that they kind of download, and you know, it all kind of happens in some kind of mystical moment of creation. You know, like that. To me, the antennas kind of speak to those aspects of the creative process as well. Like where you do have this strong sense that something is coming in from the outside, and I think, you know, that it's not just you as the creator that's the agent here. There are other agencies that are kind of flowing into what you're doing.
Yeah, no, absolutely. I mean, I think the point at which, you know, for me, drawing and the VLF antenna, which is the very low frequency antenna, and the loop antenna sort of joined together, is the point that they jumped from, I guess, a lot of research into antennas and more a sculptural relationship to antennas. And then, I mean, that the work, the oscillators had a solar panel on it which was pointing at the light, and that's where it got its energy from the gallery lights. But it was like there was something missing off that drawing, and it was the energy, was the drawing of a gathering system, so the coil, it's sort of like the secret of the coil. The secret of the coil. Right. You know, the reason why there's so many kind of spirals and coils as being, you know, this mystical entity is because it has this fabulous secret, which is that energetic activity. So energetic activity in the air creates a current in anything conductive. And the more turns you have, the stronger it gets.
Right,
The bigger it is, the stronger it is. So, and this is the principle. Induction is the principle that sits at the beginning of nearly every single electronic device. And, I mean, we've got transformers. This is a transformer. Our whole electrical grid runs with transformers that transform, you know, 250 kilovolts to 240 volts, down to 12 volts or 5 volts or whatever it is. So this transforming of energy is done with interlocking coils. So the energy flows around a coil like that. And when I don't know if you've obviously seen a transformer. It'll be two coils. And the first coil, usually they interlock them. So the energy that runs in one coil creates a current in the other wire. Now, depending on how many turns there are, you'll get either, so if you've got 240 volts in this one, you'll get 12 volts out of that one. And for anyone who's played with electronics, they'll know that, you know, it'll have taps on it, and you can have 5 volts coming off there, and you can have... it just depends how many turns are on it. But then if you take... so there's this really fabulous problem, which is to do with flow. which is that right at the beginning of every electronic device, electricity doesn't flow. It doesn't flow through into the system. It stops. It just goes around in circles here. And it's just that this one sits here and it's induced into the second one. So it's broken right at the beginning.
I like that at the switch. You like
they're not connected.
Yeah. Oh right. Okay. Yeah. Right.
So induction.
So this is after you've turned on the power here.
So then and it's just going round and round and round here, and it's doing its sort of 240 volt thing here, and then you've got you've got your device, which has just for example your mobile phone. So you've plugged in the 240 volt one, and then it's got the 5 volt one, which is the USB. And it's got a 5 volt coil there, and then that sends up 5 volts, but they're not connected.
Right. So it is actually it's doing
right at the
and it's doing kind of what your drawings do in some way.
Yeah. Well, then it's the principle. That's the principle of induction. And I mean the principle of induction. It begins, with the right hand rule. Right. You can see my right hand bit broken there. The right-hand rule is that if you have a current flowing in a wire, you'll get a magnetic field going around the wire. Right. But if you coil the wire up, you'll get an electromagnet, and you'll get north and south, and the electricity will go around. So that's. But now, if you took a magnet and you shoved it in and out of the coil, you'll get a current. And that's how a microphone works.
Sure.
And the reverse is how a speaker works. So you've got this coil and magnet relationship that produces speakers and microphones. It's this absolute transformers. It's this fundamental way of transducing energy from one state into another. So the VLF antenna, the very low frequency loop antenna, is a big one. It's a really big coil. And the electromagnetic energy in the air, the light, all of the electricity that's flying around,
all the cosmic,
all the cosmic stuff. You can hear it in the coil. So the very first thing that I read about it years and years ago, and built a VLF antenna, and I went to Walter D. Murray's lightning field, and when you stand inside a room like a normal house, what you can hear is the electrical system. And these days you can hear fax noise, and you can hear data noise, and you can hear all kinds of, because it's all producing
all that RF stuff.
It's just producing all these magnetic fields that are coming off every wire and cable, and so we live in a really noisy electromagnetic environment. If you could walk away from a house and you go and hang out in a good distance away from any...
In the wilderness.
Yes.
Often, right? You have to get quite a long way away.
You have to get a long way away. Then you'll start to hear all the stuff that's coming from outer space and from the sun, and so you start listening to what's outside of the planet.
And this is kind of what they're doing with the square kilometre array, right? Is that they're building this big telescope that's kind of away from all of that stuff, hopefully. Trying to do that. Listen to the radio frequencies of the universe.
And they've got a cage and earth everything off so that even your equipment doesn't. Because it all electrical. It's a bit like, sorry, now we've drifted into a conversation about electricity, but it's kind of hard not to, in a sense, or the antenna, to realise that fundamental principle that sits inside the loop antenna, that sits inside every piece of electronics, as it kind of, it's quite significant understanding that then when it gets turned into a graphic. Well, this is, this gets interpreted graphically.
Sure, no, and in some way it was inevitable that what you might say might make me reflect differently about what I'm doing, But you know, I've been working a lot with stepper motors, which is the same principle, right? Like it's a big coil, right? And it's using I actually don't know, and now I need to find out more about what that coil is and what it's doing. But it's essentially a big coil that is, you know, it's an electromagnet that is generating the motion of this motor, right? And that then is being controlled. On top of that, you have like a microcontroller that will be able to generate, you know, more resolution in that, out of that basic kind of coil motor system. And all motors are, well, a lot of motors, DC motors are coils as well.
They're all electromagnets. They're all coils. They're made up of magnet wire. All that magnet wire and all those coils. It's crazy. They're full of copper and
So then you know, like the spiral drawings that I've been making, in some ways they're the same. They're that same thing of kind of making visible like what this thing is as a coil energy, right? Yeah. You know, because the patterns that pop out of those spirals are in some way the resonances of that coil. Yeah. That's kind of the conclusion that I've come to anyway with that.
There's a really esoteric. There's a particularly esoteric field of people who wind motors in mathematical configurations. Richard Keen's very interested in all of that. He's winding these crazy motors that will, you know, throw
have different kinds of resonance, or
they've got different kinds of resonances. I mean, he's just making things jump around,
right?
But they go at a different frequency depending on he's interested in all those I guess archaic mathematics that but that's very interesting. You've obviously got a very complex, a very efficient motor, but it still is unique.
Yeah, well, exactly. Yeah, no, this is the thing. It's like it's got this whole crazy set of electronics sitting on top of it, which, you know, like has produced, you know, it can produce this very high resolution kind of motion, right? And can produce very precise speeds. But there's still some oscillation in those speeds. There's enough oscillation there to kind of produce patterns at certain frequencies, like where I've noticed that if I attach a bigger sheet of paper to it, that they might disappear. Like those patterns will disappear, and I think it's to do with that it's now driving at a different there's a different amount of power going through it. Yeah. So it's the resonance isn't there at that power rating, but it's there at another power rating.
That's amazing. Yeah. Yeah, that is it. Yeah, no, it's fascinating. It's really fascinating. It sort of tells you a little bit about what a strange. I mean, electricity is so strange. We don't really understand it. Not really. Yeah. Well, and the language. So to go back to your original word, to use the word flow is just. It doesn't flow. Yeah. The water analogy is a bad one.
Okay, I was going to ask you about that. Because why is it a bad analogy? Because, you know, people talk about tubes and the size of the tube and the amount of water that's flowing through the tube, you know, to try and describe what's happening with electricity. Why is it a bad analogy?
Why is it a bad analogy? Yeah. Because firstly, it doesn't flow. And in fact, the word electricity almost means too many things for it to mean anything at all. Right. So I started to read these articles from sort of maverick mathematicians from America who are really whinging now about how electricity's it's taught in schools and how it makes it completely incomprehensible. Sure. Because none of us can really understand it.
Yeah, I've been baffled by it. Like you're just doing simple, like, you know, circuit diagrams or whatever, you know, and just like, how does this even work? Like, why is this component here? Or, you know, like those kinds of explanations never seem to add up to anything.
Yeah. I mean, it's a bit like, he was saying, it was a bit like if you imagine that when I spoke to you, that the sound so sound is air pressure, changes in air pressure. But if the air that was at this point here arrived at your ear.
So right. Yeah. The very same air that is now. So I'm just sending you this perfect stream of air.
That's right. That's the kind of electrical analogy. That's what we're kind of being asked to believe with electricity. We're like, oh, it flows. It's coming from here and it's going to there. Yeah. It's not.
Yeah.
Copper wire or the graphite is a matrix, and the energy moves through it.
Yeah.
It doesn't move. It doesn't. And it's instantaneous, pretty much, It's not this bit that arrives here. It's, in fact, the state changes there and this state changes there.
Yeah.
There's a state change right across the system.
Yeah.
So you've got state changing and potential difference. And, it's very curious. That there are, as I said, I can give it to you, these maverick kind of people who are really contesting the American primary school system for baffling everyone.
Yeah.
But it's across the board. They're whinging across the board.
Yeah. I mean, if you go and try and research this stuff online, you'll come across you'll definitely come across that water analogy.
Yeah, the water analogy is no
everywhere.
Good. No good. It's got like a really fundamental problem sitting at the beginning of it. Yeah. Which is the idea that it flows. Yeah. Because it doesn't.
Yeah.
It changes. There's state change in it.
Yeah. Why is that such a hard thing for us to get our heads around?
Yeah, it's a bit like, when we think about sound, it's a good way to talk about it, really, because you can think about, you can totally accept that, the air that's at my mouth that's getting pushed around by me speaking is not arriving in your ear. Yeah. That somehow that air pressure moves through the air.
Yeah.
Yet we can't take that one on board with electricity.
Yeah.
We don't really get that. And there's a few other, there's a whole bunch of other things about, things getting very highly energized.
Yeah.
And very active.
Yeah.
And being instantaneously in more than one place at the same time.
Yeah.
So
maybe it is like a kind of fundamental problem with the way we think about energy, how energetic systems, and
we don't have many tools for it. I think certainly in the exhibition that I had with David at the MCA and the conference that we did with Doug and his book, and I think that definitely there's a real lack of language around energy.
Yeah.
It's like we're almost at this time where I guess in the 90s everyone encountered sound art as the kind of post-object art form.
Yep.
And we all learnt about resonance and and we all learned about all of the things that sound does and how it's invisible force kind of thing, but the soundscape and stuff. And now, but we also learned all the tools of frequency and pitch and we learned all of that stuff. But now, and speed of sound and whip cracking and air pressure and, we learned the difference from the electromagnetic spectrum.
Yep.
But it's still, we're right at that point where people are now, I think, starting to really work with energy. Yeah. And I think there will be more tools and more words that are coming out of it.
Yeah, because I wonder, also, I think that's interesting, because I think in some way, like the kind of work that you've been doing makes it very tangible, it makes it, and it does have this kind of, pedagogical function, in many ways. If you want to learn about electricity, you can do it with your works.
That was very much at the beginning of that. I really wanted to do the really basic stuff.
Yeah.
Because I didn't understand it.
Yeah, and in some way, like the fact that this guy was scrawling his explanations of electricity on your work, just shows that they work, right? As tools for kind of learning about some aspects of what it is.
Yeah, no, there's a general knowledge is not very good. Most people, it's a bit like maths. People kind of go, oh no, I'm no good at maths. Yeah. It's like, hang on a minute. Hang on a minute. This is abstract language.
Yeah. And you can learn it.
You can learn it. And you're just refusing to acknowledge it. Yeah. And it's actually really interesting. Yeah. And the same with electricity. Oh, no, I don't understand electricity. And I don't know how many times I've explained induction in my recent life. Many times. Sure. Yeah. But that it's, I don't know. I think it's very strange. Yeah, but I think, certainly the word electrosonic is appearing now. Yeah. So this is not just electromagnetic, but electrosonic, listening to these sounds that are coming from these energetic devices. Yep. And a lot of it, I think, with my own work, I think, so I made a whole set of tables. Yeah. Yeah, and those tables have got oscillators on them, but they don't look like, they're not a circuit diagram oscillator. So they are LDR, so they're induction, LCR, induction, capacitance and resistance. And this is an ideal system. Right. So these are clocks. Yeah. So in your... Yeah.
The quartz crystal, right?
Quartz crystal, yeah. So you've got a power supply, and then it takes a certain amount of time for the storage system to fill up, and that is determined by the resistance in the system. And then, so the induction coil is getting pumped by the air or by you touching it, and then it fills up and empties. So it fills up and empties, and it acts like a clock.
Yeah, at a certain cycle.
Yeah, and so I've drawn these things and then had to put the oscilloscope on them to work out
what the cycle was. Yeah.
And it's it's up in the megahertz. They're very high. Yeah. So you can still hear them. If you touch them, you can still hear the low frequency stuff. Yeah. But you're not hearing the upper frequency. It's sort of where I guess it's the next step for me is to let people hear their drawings clocking. Yeah. So then you don't even have to touch them. Yeah. They're just clocking on themselves. They're just producing a frequency. Yep. And they're not, and those components are now don't look anything like the diagram, like circuit diagrams.
Yep. So, because the oscillator, what does that do in a typical electronic circuit? Like, what is the
just flips? Yeah, it just goes up and forward and backwards. Right. So the energy is just going forward and backwards. Yep. At a frequency.
Yep. And it's used to kind of keep time for. Is it?
Yeah. So they so you've got clocks, electronic or the circuit diagram. The circuit component of a clock holds things in check. I guess it sort of it lets them all know where they are. Sure. And this is like this pulse that's driving everything. Yeah. Kind of the heartbeat in some way. A lot of electronics got a little heartbeat thing, kind of holding it all together. Yeah. Otherwise, it'll just be a bit random. Yeah. I guess. Sure. I don't know. Yeah.
Well, clocks also have this kind of massive evolutionary history, right? Right to microorganisms, that have clocks in some form or another, right? And clearly, like there's a really strong evolutionary imperative to incorporate some aspect of at least the daily cycle, into your organismal functioning. Because if you know the sun's coming up, then you can start to prepare for that to happen, and the energy that might come into the system at that point. I don't know if they've found a microorganism that doesn't have some kind of clock in it. Yeah.
That's right. Yeah. That's right. Yeah. And that's what's so weird, because so that it shifted from just single antennas, which are just energy scavenging or listening to the world outside or just bringing the outside in, to these things which are now, you can almost close them up hermetically if you wanted to. They don't necessarily need, and they're just clocking on their own, and they don't look like an electronic circuit anymore, but they're working. They're clocking. And because they're capturing energy, they're storing it, and they're releasing it just all in their own, just with this forward and backward.
They have a kind of metabolism in some way. Yeah.
And that's really weird. It's like, so, just to go back to that question you asked earlier about what do artists, I guess, bring to science, I guess you could say, in this sense, normally that sort of thing would be minuscule. A clock, if you had an electronic clock inside a piece of electronics, it'd be tiny, absolutely tiny. This is like now a table, and I think some of those clocks have gone onto the outside of buildings. I haven't really called them clocks though. I've called them curve oscillators. They've mostly been called oscillators. I've just called them oscillators. It's taken me a long time to really understand what they are, and also understand the scope of the forms and the shapes that will do it.
Sure, right. There's all sorts of things that these things could potentially be, like all sorts of forms. That they
so the most recent one. So there's one now that will get exhibited at UTS, I think, as a part of the Spectra, the Experimenta exhibition later this year. And the energy gathering system is based on licon.
Right,
but it's a really complicated sort of... So
the geometry of licon, basically. Right.
But the geometry of licon reduced to a single line that doesn't cross over itself.
Sure. Going back to those old fractal guys.
And then on the other side is a line that runs parallel with itself and never touches.
Right.
So, and never touches itself and never joins the two lines together. So the joins don't join together, they're just a storage system. Right. But it's packed in, and it's also based on lichen structures and on Voronoi patterns. So Voronoi analysis of kind of objects reveals these kind of structures and patterns, and then they can be reduced to lines.
So you could take like a photograph of a lichen and plug it into this system and then get a bunch of lines out of it.
That's exactly how I got it. So I've been up here in the Blue Mountains. And I mean, there's lots of structures here that I'm really interested in terms of their energetic forms. So I guess it shifts from being, working with diagrams of electronics to thinking about if fractal antennas are descriptions of nature, bad ones probably.
But too like overly simplified or something.
Crude and oversimplified. Then that's sort of, and they work perfectly as energy scavengers. Then let's have a look at nature and see what kind of forms are appearing out of that, and could you plug them in and use them? So, and lichen is a really funny, everywhere you go, it's like this really strange little structure that's growing on rocks, and
it kind of helped to terraform the Earth, right? In the sense that, in evolutionary time, it's kind of, they predated all the plants and fungi and whatever that later would colonize the dry earth, and basically broke down the rocks to form soil. Right?
Oh, really?
And So I mean, it is a structure that has produced all of these other structures on some level. Like that.
So it has its own kind of energetic. Evolution what it's up to doing things. So it breaks things down.
Breaks down rocks. And because there was no soil, right? At a certain point, there was no soil. It was just a bunch of rocks, right? And so how do you get from a bunch of rocks to soil? Well, you start with lichen.
Like lichen.
Yeah, yeah. And you know, like you see them growing on rocks and you kind of go, oh, they're just growing on the rock, you know, like, but actually they are breaking it down.
Yeah.
You know, and you know, over millions of years, you start to make soil out of rocks through the action of lichen, and then you can get, you know, other plants growing, and you can gradually increase in complexity to, you know, to kind of whole forest ecosystems, you know.
It's interesting. So are they, unlike fungi, which doesn't photosynthesize, are they are also kind of like in this other working with the nutrients underneath them, breaking the nutrients down underneath them, or are they looking at the light?
Yeah, no, definitely. They're definitely because they've got the algal component, right, and the fungi component.
So they've got both.
Yeah.
All right. So they're kind of like, so they're also photosynthesizing, because that's the other thing. I just think that's the smartest thing in the world, photosynthesis.
Yeah.
I mean, seriously.
Yeah.
I mean, we're not very smart. We have to eat plants.
Yeah, that's right.
To get energy.
Yeah.
Plants just turn sunlight directly into energy.
Yeah.
And so do all those underwater creatures.
Yeah.
You know?
Yeah.
But then fungi are kind of like breaking everything down. There's the sort of nacreous kind of the breakdown. They don't photosynthesize at all. Mushrooms don't photosynthesize.
Yep. They're doing the work of kind of the decomposing business, recycling all those nutrients for, you know, so the plants can kind of use them again. Yeah. But the lichen, you know, is so interesting because they do have this kind of photosynthesizing partner in the symbiosis, and then they have the fungi, and it's that interaction between them, and there can be, you know, there can be like up to 4 partners in some of these lichen for different organisms, and the fungi that are part of lichens, they can live as independent organisms. I mean, this is the interesting thing about lichen as well, is that both the fungi and the algae that are in lichen a lot of those species can live independently. So they're not like the chloroplasts that are in plants that are fundamentally integrated into the organism.
Right.
You know, they're actually still these organisms that can potentially have their own independent lives, but they come together and they make lichen, which is kind of, you know, like I don't think there's too many cases. They're kind of their own kind of special thing in some way as an organism, you know.
Amazing. Well, it's I mean, I must say that there's a kind of representational mode going on there for me. It's kind of representing them, I guess, is or looking at the structures that are appearing inside that, and using different kind of computer image analysis to get that out of there. Which is also, I mean, Voronoi is fascinating, that how that works, and I mean, it identifies, I guess, so many of the cellular structures in organisms. Right. But it also is used.
So they use it. Scientists would use it. Biologists would use it to do that sort of work. Right.
So but they also use it to look at how things kind of populate areas and. Delaunay, Sonia Delaunay's famous fabrics were all Voronoi. It's kind of found its way into design as a. I guess it's like one of those. I'm not sure. Not sure that I really have kind of got to the bottom of of all of the Voronoi, but I have started to see. I've started to see it. In the rock structures, Voronoi structures.
Sure. Yeah.
And where you start to see everything kind of squashed in together.
Yeah.
You see everything getting packed.
Yeah.
And it gets packed in a particular kind of way.
Yeah. Well, it's like sort of like the strata here in the Blue Mountains.
Yeah.
Yeah.
And it's funny, it's one of those things about
Mm.
looking at computer analysis or looking
Mm.
at modelling or looking at 3D,
Mm.
where you're looking at, or even looking at fractals, where you're
Mm.
suddenly looking at a simplified version.
Yeah.
And then you walk back out into the world and you think, that's, it's there.
Yeah, sure.
I wouldn't have seen it.
Yeah,
if
once
I
you have the
hadn't-
eyes for it.
I wouldn't have seen it
Yeah.
unless I'd looked at it.
Yeah.
I'd looked at this really simplified version of
Yeah,
it.
yeah.
So it's quite useful in a sense that, and maybe that's, I guess, what computer drawing.
Mm.
And it's funny, I guess no one really talks about computer drawing much these days. It used to be a kind of...
gone out of fashion or something.
Yeah, it's gone out of fashion. Or mechanical drawing,
Yeah.
or all of those sort
Yeah.
of things. Or I guess there's computer-aided drawing, you know, CAD drawing.
Yep.
But we don't think about it as an analytical tool or an educational tool for then going back to see that, to see some kind of process unfold in the world. You know,
Yeah.
or the bare bones of something.
Yeah.
It's a bit like, you know, drawing a body.
Yeah.
You know, the more you look at something, or it's
Yeah.
the careful looking or something.
Yeah, it's kind of the way you're describing it there makes me think of that it's like the scalpel to, you know, reveal anatomy, you know, like this kind of old fashioned kind of thing of kind of
the life drawing.
The life drawing.
The anatomy experiment, you know.
Yeah. And,
the drawing was all of those things.
Yeah.
You know, it has been all of those things.
Yeah.
It's been very careful observation.
Yeah.
So the observational side of drawing is, I think, is interesting as well. And it's certainly, you know, I mean, it's been there for a very long time, and it will always be there because people will always do life drawing and nature drawing and, you know, still life, these kinds of drawings and landscape drawing. And so there'll always be this observational side of it. But, it's interesting when you train your eye.
Well, absolutely. That's kind of what it is in a way, isn't it? It's like the equivalent of actually, you know, just going out there and doing a whole lot of sketches, like you know, training yourself to look at it in a certain way. But you're doing that by looking at these patterns, you know, on the computer or generating them from photographs. That you're training your eye to look in a certain way, and it becomes like a vehicle for doing a kind of observational drawing, you know, in some way, like where you're like it's an observational drawing of the lichen, but it is an observational drawing, not so much in the sense that it's you've sat there and drawn the lichen, but that it's changed the way that you look.
Well, it's an interesting kind of question, actually. You know, we should sit down and draw the lichen.
Yeah, sure.
Because now when I think about it, I think, well,
you would probably draw it differently because you've seen it from in those ways.
I wonder if you were to do a drawing exercise on drawing lichen, whether you said, now draw it with one single line, you know, or
sure.
you know, I mean, you know, in the same way that there are all those different drawing exercises for life drawing. You know, it sort of makes it really interesting to think about what that might uncover when I add it into the mix of where I think it might go. Or what I'm sort of looking for in a sense is looking for how those patterns emerge out of, or how energetic patterns or energy gathering patterns or or a kind of electronics that's not, you know, I mean, electronics becomes not a good word really, but they're energy gathering systems that are occurring naturally. Which is
so. There is this kind of thing then of like what that structure comes to signify, you know, in some way when you take that lichen structure and you put it through this computer program and then you generate this version of it that is this energy gathering system, like it becomes a representation of one aspect of what the lichen is doing. You know, and so it has that kind of representational quality on that level. you know, not just on the level of the shapes that it's making, but it's a representation, you know, of one of the things that the lichen is doing. Yeah.
No, it's definitely gathering.
Yeah.
It is. Yeah. It's interesting.
Yeah.
I mean, I've tried to do that with the carbon copy reactors too, in a really different way.
Yeah.
To look for, I guess, what is so the carbon copy reactors are made with photocopier carbon, mixed into a kind of Turkish marbling kind of mix, which is incredibly tricky to do.
Yeah.
And then
lots of careful measuring of amounts.
So lots of experimentation, and then put into water, and then picked up with beautiful Stonehenge paper, which is the paper that you do with the printmaking paper.
Yeah.
And
it's because it has the right kind of absorbent quality.
Yeah, because it's not sized.
Yeah.
It's quite funny because, you know, all of to make the Turkish marbling is very secret.
Yeah. Right. Okay.
You know, because it's
it's
like making
craft.
ink. You know, it's like trying to make your own ink. You start trying to make your own ink. Because I started at one point trying to make suminagashi, the ink that floats.
Yeah.
Out of carbon.
Yeah.
And ink that floats, which is a Japanese suminagashi.
Yeah.
But then to make a black ink, suddenly you're in the Middle East.
Right.
And there's this whole history of ink making that's really secret.
Right.
And then ink that floats and ink making, and it's got like bull's gall in it. So,
right.
Bull's gall.
Yeah.
Bull's gall. You can buy it in the shop.
Bull's gall, you can go to the butcher and say,
no, you can buy it in the art shop.
Right. Okay. Right.
Bull's gall.
Yeah. Right.
And shellac, you know.
Okay.
It's got all these kinds of things in it that were sort of, you know, the beetles. Or it's got the beetle wings and the bull's gall. And then really strange ingredients that make up these particular kinds of, whether it was a Middle Eastern ink for writing a sacred text or whether it was for floating ink in Japan. But there's these strange... but so adding photocopier carbon into it, which is super fine.
Yeah.
And
electromagnetically you see charged. It kind of leaking out of the photocopier, right? Is it that stuff?
That stuff that'll stick to everything because it's all charged.
Yeah.
It's very sort of charged.
Yeah.
But once it goes into the water, you get it into the right mix. You get the closest I've ever seen to sort of like a Mandelbrot kind of pattern coming out, like these cellular structures.
Sure. Yeah.
And they're very, very much a sort of the long carbon chain.
Yeah.
And they're really fascinating. And I haven't worked out. They are just drawings.
Yeah. You're not plugging them in.
I can't plug them in. I can't plug them in. They're too tiny. But they're like, you know, it feels like they're super fine. There's a whole other technology sort of hidden in there, but maybe something between, you know, surface tension and all of those parameters between carbon and photocopier, you know, the reprographic technologies, the carbon copy, which is really curious as well. Sort of opens up under that rubric.
Sure.
This strange kind of what carbon is capable of.
You
know, as informing its own structures.
Yeah.
Which we're surrounded by, really.
Yeah, we are those structures.
We are the structures.
Of carbon on some level, right?
Yeah.
Which kind of, you know, it's, you know, when you're talking about how these super fine structures that in some way they probably have their own energetic properties that are, you know, maybe a little too difficult to kind of fully probe or... you know, or plug in at least. But you know, like there's definitely that
maybe it's a drawing.
Yeah,
maybe it's a
sure.
maybe it's a kind of technical drawing. It's like a technical drawing in that sense. It's like what it reveals is a structure.
Yeah.
That can be translated into something else.
Yeah.
So it requires translation. It can't be simply like that. But
which was kind of where I was going. Thinking about it, how it in some ways reflects all of these other types of structures that are all around us. That particularly in the biological world, but even in the kind of non-living world of rocks and whatever, right? That there are all these structures all around us. And I think you actually had a project where you were trying to drill into and plug an antenna into some of the strata.
No, we've definitely that. I mean, that's a kind of whole another thing. I don't know if it's really connected to drawing, but it's certainly that's an idea about some of the structures here in the Blue Mountains.
Yeah, these geological structures that potentially gather energy in various ways.
Yeah.
And I think certainly like the biological thing, like they there is that kind of, coming back to the marbling works, there is that kind of cellular structure that I think speaks to the biological organization of cells, or like what's going on, the networks that form, and maybe at neurons, like the kind of flows of energy around bodies that and that networking of bodies and cells.
And it's interesting because there's a couple of things that were really curious in there, which is water being the first one, things being created by things self-organizing
in water. Which is biology, right? Like that's our best guess about where life came from.
But suddenly, Turkish marbling just seems like, and Suminagashi just seem like so crazy. They seem so interesting because you've got this kind of like self-organizing. You've got these like self-organizing drawings that are happening in the water. And depending on what it's like once you.
So the other ingredients is probably like just worth pointing out the other ingredients that go in, because there's oil, right? And when you're doing
there's oil.
So
it's just oil. It's in this one. Well, in the ink, there's all these other really strange things like shellac and bull's gall, and it's quite no book that you can find is going to tell you what the quantities are.
Sure.
And so it's really very experimental.
Yep.
But the Turkish marbling goes from incredibly simple states. I mean, people Turkish marble with oil paints, really.
Yeah, sure. Yeah.
But for me, it's the electrostatic carbon from the from the photocopier, and then I did a lot of work on the oil.
Yeah. Because the reason I bring that up as well is because the oil is like we were talking about origin stories about life. There has to be a membrane, right?
Yeah.
And the oil is like posited as kind of creating these like membrane structures. Like that you need some kind of source, some form of carbon that is maybe capable of creating the membrane structure.
Yeah.
And in some ways, like when you see all of the in those marbled works, you see all these kind of cellular structures. That's maybe because the oil has created a kind of membrane that the carbon is sitting on, or
the optimum mix doesn't leave oil in the water.
Okay, yeah, right.
Yeah,
right,
so
right.
Even though there's the optimum mix is a tiny drop.
Yeah.
And then it spreads really quickly.
Yeah.
And there's kind of like a moment where it's there, and then after that it just breaks apart.
Right.
So it's kind of the surface tension, and it's dissipating. So at first I thought it was like a dissipation structure.
Yeah.
So it's like it's being driven by dissipation, and so because it doesn't come back together again.
Yeah. It's entropy in action.
Very fast, quite fast. And then there's an optimum moment where it's sort of settled down. There's there's lots of conditions, temperature, all the quantities, everything, and the size and everything to get an optimum result where you get large structures.
Yep.
Otherwise, you just get like a mass. I think I might remember the very first ones I did are very dense.
Yeah.
It took a long time to get it to kind of to get it into a more open structure where you could see it.
Yep.
But but the thing that really it's self-organized. It self-organized itself.
Yeah.
That was what really caught me.
Yeah.
And so if you look at all of the things, again, that connection to the world around us is that it's self-organizing.
Yep.
They're the self-organizing principles that no one's to make something, to make an antenna. If you wanted to work at a nanoscale, you'd want it to. It needs to self-organize.
Yeah.
All you need to do is give it the correct set of initial conditions, and then it will build itself.
Yeah. Which is what so much of biology does, right? So many of how these incredible structures exist in living organisms. It's through that order poetic self-organizing aspect, right?
So to create a system that can do that is really curious. Like it's really puzzling.
Yeah.
A very puzzling thing. The question, I guess, that came out of it really when talking to the Nano Lab was, let's take one of those structures and 3D print it in graphite and plug it in.
Sure. Yeah.
Let's have a look what it's up to.
Yeah.
Which is, I guess, that's that question that goes back into the world, which is with the geological and stratified structures that I was kind of interested in. Is what are they doing?
Yeah.
How do you even ask that question? What do you have to do to find out what they're doing?
Yeah.
Because they look like it makes sense that they would be doing something. For lots and lots of reasons. Yeah. But how do you
find out?
How do you find out what that is?
Yeah. In some way, there is this aspect of it which is like part of our problems. The problems that we're talking about in thinking about energy. And what that is I think partly a cultural problem. It's a problem with the way that we conceive of it and how we use it in our culture, like this kind of utilitarian efficiency aspect of it, So, and the fact that we think about it as flow, even, maybe is related to capital flows and like all these other kind of conceptions of flow that
it's not itself.
Yeah, exactly. It doesn't have it. It's not its own entity. Whereas if you're coming at it from a different kind of cosmology that maybe recognizes spirit or entity, a more animistic kind of way of thinking about the world, then maybe it's easier to get your head around what electricity is, maybe like to kind of coming back to the
like the supercharged kind of things. No, it's really it's I guess absolutely. It doesn't. It feels to me like there's still more to there's a lot more to understand. And I mean, and it is interesting because I think that in some really weird way, drawing kind of is like this really strange tool for helping you to understand things. Maybe for all those experiences of drawing things, of drawing people, of drawing. And then of using it to conceptualize space, of I guess in the expanded sense of drawing, seeing it around you, that observation, it's certainly teaching. It's a mechanism for understanding.
There was this dude who has this. Actually, there's this. One of my favorite podcasts to listen to is this really nerdy science podcast, which is This Week in Virology, and I like it. I like it because of all the things that you could listen to, right? But I really like it because it you get a sense, without fully understanding the technical aspects of the discipline of virology, you get a sense of something happening on a technical level, right? You can listen in on these conversations between virologists where they're talking about all these different processes and techniques that they're using, and even if you don't know exactly or can't fully follow what they're talking about, you can kind of glean something of a process happening, which I think is, and I think that's really important, that we don't reduce things to like the object, that exists out there, and that we have this insight into process, into thinking processes, into what's happening in terms of process. In some ways, I think that's part of the problem with misconceptions or misunderstandings of science, is that we've become completely disconnected from the process of what they're actually doing.
Well, that's the other thing is that, and you probably have it, people say it to you, is like, have you studied science? I'm like, yeah. Physics is the world. Yeah, it's not, scientists are not necessarily the only people who think about the world. Sure, exactly, or who are thinking about how things work, or who can think creatively about how things work, or who might investigate it or invent it. And it's not even the question of outside of science or outside of physics, which I think is really interesting as well, the untrained physicist. But I think it's actually, there's something more fundamental than that, which is, this is our world. It's not just because you happen to work with the functionality of the world, or you're exploring the functionality of the world, doesn't mean that you had to have studied science or that you are a scientist.
No, for sure. And actually, really this weird. Is kind of and this is kind of where I was going with the This Week in Virology thing. Is that, there was a discussion of art on this program, which was kind of interesting. And anyway, the idea came up that that those cave paintings, from this kind of science-centric kind of point of view, that those cave paintings were like the first peer-reviewed journals. That in some way this is like us as a species posting our findings about what's out there in the world, and having this means to kind of communicate it on some level, that and in some way. In some way, I don't kind of mind that idea. I think, like, if we kind of think about it, in some way, like, there is this, I think there's always been this aspect to drawing and mark making that is really fundamental in investigating the world around us. And that continues, and now we've just reached this strange point where disciplines have kind of diverged to the point where you look at all those sort of bird drawings, all the biological drawings. The Blanchet's, they made their things in glass. They were the scientific, that was the scientific record. It's huge. It was drawing for many years as a way of recording the world. Sure, exactly. Like it's our first recording technology, right? Like drawing. It
has this like really fundamental relationship to science and to the world around us. Or maybe to the world around us. Possibly art, that kind of drawing. I guess it's still, I think about when I did the Objects and Energy show at NAS, downstairs was that amazing exhibition of the bird drawings, the scientific bird drawings. It's huge. When I studied drawing at RMIT in 1977, I had to do nature drawing, and you were only allowed to use an F pencil.
Right. What is an F pencil? I don't even know what an F pencil is.
It's kind of like somewhere between the H. What is it? The hard, the H pencils. Yeah. It's right between the middle H and the B's is an F.
Is an F, right? Okay.
And you had to spend a year. You were only allowed to draw with the F pencil.
Wow.
And it started with sticks and leaves. But she had beetles. She had lots more other stuff in there, you know.
Yeah. You start with the sticks and then you can get onto the complex.
She'd been teaching that for, I think, a very, very, very long time. Yeah. At the time, I think I was incredibly dismissive of it. But you didn't have a choice. Yeah. You just had to do it.
You had to draw the sticks.
You had to draw sticks and leaves and hope to get to a beetle at some point.
Sure. Graduate to a beetle. Yeah.
But I did it for 3 years.
Yeah, wow.
I was part of the RMIT gold and silversmithing.
Yeah.
And in the end, I loved it.
Yeah.
Absolutely. I think so did everyone.
Yeah.
And it was just this quiet time that was concerned with very careful and exacting observation.
Yeah.
It was fascinating. I did eventually bring a giant corn plant into the class in the 3rd year, and I said, I'm going to draw this every week for the whole year, and that's it. And I drew it every week for the whole year.
That's great.
So I had this whole series of drawing as the thing slowly died.
Sure, yeah.
But it was so, I was so compelling. It was the most compelling kind of investigation into, to spend I think it was a semester, not a year. I think it was the final semester. I figured it didn't matter if she failed me. Sure. I really should do what I want to do.
Yeah, and that was it. Yeah.
But they don't, that kind of... So, that was in a art school.
Yeah. And it is like what you can come to know when you like observe something in that level of detail, is really important, right? And it's still a huge part of...
Well, it's in your work as well.
Yeah,
there's like incredible observation and incredible attention to detail, and there's nothing... you can say it's full of expression.
Yeah.
But it's exacting. There's an exacting kind of expression in there, which is really interesting, because we just associate expression with something that's very loose, and we don't think about it as being exact.
Yeah. That's something that I definitely think about. Is like that expression. Like expression. There's so many dimensions. It's like this incredible multi-dimensional thing, and you can dial in on a really narrow band of what expression is. You can really kind of dial it into something. That's very, and that can be, an interesting process of dialing in and then maybe dialing out again, or like modulating how what those bands of expression are. Because it's what constraints do you put around it? Like where do the boundaries exist? I think that's a question that's always been there in any expressive work. Is what are the boundaries of the expressive work? Because if there are no boundaries to it, it's a mess. It's a fucking mess.
Well, I guess that's one mode, is to go into the mess.
Sure,
and a lot of people do, and that works for them. I don't necessarily think that's not a valid, and not a valid. And that is a very valid, and sometimes the mess is good.
But I think there's a misconception that a bit that the mess is expression. That's
right. It's not. Absolutely not. There's
because at a certain point in the mess, like the mess can be great, but at a certain point in the mess, the expression gets lost. For me, anyway, for
me too.
The noise has overwhelmed the signal. And
I'm someone who likes noise.
But I think there's a really interesting relationship between noise and signal in your works. I think that's one of the things that...
Well, noise becomes signal.
Exactly.
In fact, in those works, which is really interesting. Because in any other situation, I have had people go, it's not working. I go, no, that's it. That's what this is supposed to be getting. And they're like, right. That noise. And I'm like, that noise. So there's a question, but I guess there's still inside the noise. We're always kind of looking for coherence. We're looking for the signal in the noise, or the melody in the noise, or the modulation in the noise. And that is, that's the history of radio.
Sure.
Is in there listening to outer space. They were trying to wipe the noise out, and then they realised it was the noise.
That's right. They were
trying to filter the noise out, and then they realised, no, wait a minute.
The noise is the signal.
The noise is the signal.
Yeah.
Which is curious, but there's something really fascinating about, and I guess it's the complexity when it becomes too complex.
Yeah.
You can't see it.
Yeah.
You can't see it anymore.
Yeah. Yeah. Which is where that kind of modulating aspect is so important. You know, like as in terms of revealing structures, right?
Yeah.
You modulate it to a certain point and something pops out.
Yeah.
And then you know, and then maybe you can go back into a noisier state because you know what to look for now, you know, and coming back
that's
to
exactly
that
point.
Yeah,
the point we were making before about it's almost like you're educating.
Yeah.
If you're working with a simplified version of something, whether it's a computer analysis of something or whether it's a mathematical analysis of something or whether it's just careful observation, you'll never, it's not a photograph.
Yeah.
I don't know, you know, isn't it interesting? Which is there's a really interesting point about, you know, drawing, that it's not a photograph and it will even, I don't know, I guess people do spend a lot of time trying to make it look like a photograph.
I'm trying to do photorealist stuff. Yeah.
There are people.
Yeah.
There's so many different modes in there.
Yeah. But in some way, like that, all that does is reveal its difference from the photograph. Don't you think? Like that's like the closer that you get to it, you know, all you're doing is gesturing more and more to its difference.
Yeah, and I think in the computer world and computer modelling, where it's mathematically generated or it's algorithmically generated, you get this uncanny valley thing where it's like it looks perfect, but there's something's wrong. You cannot pick what it is. You can't pick what it is, and yet I know we because we do a lot of work with
gaming engines
and stuff, and you know, so we'll have like a tree generating software, and we spend a couple of days looking at trees, and then you walk outside and you're like, fuck, the world doesn't look real anymore. Has broken the world. Stop looking.
Well, there's some really good highlighting on those leaves. Let me just adjust that light.
Just going to tweak that a little bit. You know, it's really interesting because you can break. If you kind of unpack it too far, then you it loses its chaoticness. Or it loses its noisiness.
Well, that in terms of those like super high resolution 3D kind of modeling situations, noise is actually something that, you know, it's
really important.
In terms of like stitching it all together and
it's what makes it look real.
Sure.
Because otherwise it doesn't.
So you add like a noise layer at the end of that process. Well, I guess
if you think about how many parameters you can control.
Yeah.
It'll never be enough.
Yeah, sure, yeah.
So you'll never have high enough resolution.
Yeah.
And we get closer and closer and closer all the time. But you always know that it's not. You always know, no matter how. I mean, I guess the most famous ones are the people.
Yep.
With regard to the uncanny valley.
Yep.
But the less famous ones and the most deceptive ones are the environment, the trees and the grasses. And
sure.
If you watch the grass for a while, it's got no matter how long the oscillation is on its movement or its variables, you'll see it loop.
Yeah. The pattern will be there.
Looped.
Sure.
And I don't know. Yeah, I think that
there's not enough chaos in the system or something. There's not enough to put enough. Not a way to put enough chaos.
That you know that. I mean, to me, that's a little bit of the challenge in my own work.
Yeah.
Because I've reduced it down to understand it.
Yeah.
It's sort of coming back up again into complexity.
Yep.
And to the point that with the antenna, the loop antenna with a wire antenna, I just took it off the thing and screwed it into a ball. Yeah. And it works.
Yeah, right.
It still works. Like, right, okay. Yeah. It's very efficient, actually.
Yeah, right. It works better, doesn't it?
Yeah, no, it works just as well. There's no problem.
Yeah, sure.
No problem with it. It's still doing everything that it's doing.
Yeah.
So it's quite puzzling. There's quite a puzzle there to unpack.
Yep. Yeah, and that kind of way, like that relationship between, you know, different ways of thinking about the world, like through 3D computer generated software, or through a photograph that you were processing through this algorithmic means, or
screwing everything up.
And then screwing everything up.
Yeah. What about if I just screw it all up? Does it still work?
Yeah. But there's something that about how you know, and in some way, I think another kind of fundamental aspect of visual art as a discipline is that aspect that where you do learn to perceive the world differently, you know, and each one of those different means is a different way of perceiving the world. So if you spend hours making 3D models, you go out and it's like, that tree is, you know, suddenly doesn't look as real as it used to, you know. So, but there are all these kind of aspects that, and artwork can be, another way of kind of seeing the world. You know, that you can walk into an experience of an artwork and walk out with different eyes.
Yeah, definitely.
Yeah,
definitely.
Yeah,
definitely. I think it really. I mean, for so many people, it's just changed the way that they saw the world.
Yeah.
Allowed people to appreciate things they couldn't appreciate.
Yeah.
I mean, that's probably the most recent thing, I guess. You know, we now appreciate blue tack. I mean, just, you know.
Yeah.
But I mean, there's been this shift. I mean, obviously in our recent past, we've had this like massive shift from traditional materials or sculptural and art materials into the whole gamut of materials that have gained incredible value and significance just, you know, through the everyday.
Yep.
Things completely taken for granted as having any kind of significance at all, or being a valid material are now elevated.
Sure, yeah.
So it's really...
yeah.
The world had kind of opened up, particularly for sculpture, I guess. But I mean, expanded painting. I mean, sculpture was expanded for quite a while, where it just grew and sucked up everything it could. And then now, you know, and alongside it, everything else did as well. I mean, Mark Titmarsh's book on expanded painting certainly articulates all of that, and drawing has had its as being a kind of multidisciplinary activity.
Sure, yeah.
A little bit like sound. You know, sound is this really multidisciplinary activity. It exists in all different fields at the same time.
Yeah.
And has grown out of all these different fields. And the same with drawing. You know, we've got technical drawing, we've got expressionist drawing, we've got so many different kinds. And we see all of that getting wrapped into the dialogue now. So there's no-go zones anymore. Sure. You know? There's no no-go zones. You can go wherever you want now.
And then all of those, we can have these kind of relationships with all those different types of material and different forms of materiality.
Modes. I mean, such as the modes that you're employing there. It's interesting, isn't it? It's totally opened up.
Because I think, you know, because the other aspect of that material realm to me is like a question of intimacy, like a kind of intimate knowledge that you can have that isn't an instrumental knowledge. Goes back to those kind of distinctions that you were making between, you know, science and art. It's not necessarily driven, you know, you're trying to do something with the material, but it's not like an instrumental thing that you know exactly where it's going and you know the practical problem that you're trying to solve. So out of that, because it is broader than that, there is a kind of intimacy in exploring all of those different possibilities or sets of possibilities that emerge, you know, when you think with the material every day in the studio. You know, like you know what I mean? Like to me, there is this kind of thing. There's this aspect of like, you know, like, for example, when you were describing the marbling process, where you come to know these set of materials and you come to know the exact quantities of them, and you come to know a certain motion in laying the paper into the bath to pick it up. And you,
so how come you can make 6 of them, pretty much exactly the same when the variables are just ridiculous. Like I couldn't do it now. It was like it took days to get to that point where it was like where it would work.
It would be days again.
And you probably wouldn't find the same. You wouldn't find, anyway, I think there were other things that kind of appeared, other questions that sort of appeared out of it at the end of it, where you go, oh, next time I do this, I'm going to actually change all these aspects of it. Because I want to see what will happen. You
want to explore something else, right? Or another set of possibilities.
Where it will go.
Well, I think we've done a lot of talking. Thanks, Joyce. This has been really great.
Thank you. It's been a delight talking.
Great.